Chapter 8B, Perfect Squares and Difference of Perfect Squares. So when a prime number like 3 is multiplied by itself, then the product of such multiplication, aka 9 in this case, is a perfect square number. Binomials like, for example, 3 take away 2y, can also multiply themselves and therefore to make a perfect square. So we also call a bracket squared a perfect square. Okay, so we can expand perfect square using distributive law so that we can either calculate them or simplify it with other expressions. For example, a plus b squared can be written as a plus b times a plus b. Using distributive law, we know that a is distributed to a and then to b, and then b is distributed to a and then b. Okay? So as a result, we have a squared plus a distributed to b, so a multiplied by b, and then b multiplied by a, then b multiplied by b. And because that we know multiplication is commutative, that means that ab equals to ba, therefore you have two ab's in the middle, and then you can collect like terms, and as a result, you have a squared plus 2ab plus b squared. There we have the perfect square formula. That's a plus b squared equals to a squared plus 2ab plus b squared. Okay? So using this formula, we can speed up our expansion of perfect squares. But if you don't memorize this formula, you should be able to expand it yourself using distributive law and arrive at the same answer. The key is that if you memorize this formula, apply it correctly, you can speed up your calculation by a lot. Similarly, we can derive the formula for a minus b squared. Okay? So we know that a minus b squared is just a minus b multiplied by a minus b. So we distribute the first a to a, we should have a squared. Then a to negative b, we should have a negative ab. And then negative b to a, we should have a negative ba. And then negative b to negative b, we should have a positive b squared. Okay? And then commutative law applies. The middle two terms can be collected together to become minus 2ab. So you notice that the sign for a squared and b squared remain the same, okay, with the same as a plus b squared. The only thing that changed is the cross term, that is negative 2ab. So if it's an a minus b squared, you should minus 2ab in your answer. And if it's a plus b squared, you should be plusing 2ab in your answer. So as a result, we have the second formula in the case of a minus b. That is also a squared plus b squared, but then you have minus 2ab in as a cross term. Okay? I highly recommend you to memorize these two formula correctly. Now, let's try to apply this formula. Well, the normal method when we want to expand the expression 2x minus 3 is to use distributive law. Okay? You write it as two brackets multiplied together. Then you have 2x multiplied by 2x. Then 2x multiplied by negative 3 multiplied by 2x, and then negative 3 multiplied by negative 3. You do the calculation, then you collect like terms. That's your answer. Well, now that we have learned the perfect square formula, we can apply it. Okay? In this case, your 2x is your a, and your 3 is your b. And then in this format, it's 2x minus 3, so we are applying the formula for a minus b squared. Okay. So you have 2x, because 2x is a, so notice that I have used a bracket, and this bracket is necessary. You cannot not having this bracket, okay? Using the bracket, I make sure that the entire a, the entire 2x are squared. So in the end, you will have a 4 times x squared out of the bracket, okay? Then you're taking away, because you're using the a minus b formula, then this 2 here is in the formula, because you need to minus 2ab, remember? Okay? Then you have the 2x, that's your a term, and you have the 3, that is your b term. And then plus b squared, b is just 3 in this case. Okay. Then you have 4x squared minus 12x plus 9. So you notice that if you apply the formula correctly, you will arrive at the same answer, but a lot quicker. Alright? Then, last, but actually better. Okay? So, difference of perfect squares. When you hear politicians talking about diversity, makes it even better. So, difference of perfect square is even better than perfect squares. I'll show you why. So x minus 2 multiplied by x plus 2. Right. Same number, but different signs. You notice that the two terms are sort of same. It's x2, but they're connected by different signs. Therefore, we call it a difference of perfect square. Because these sort of like perfect square, but they're different. Okay. When you expand that expression, you notice that it becomes x squared plus 2x minus 2x, and then you have a term, the constant term will be minus 2 multiplied by plus 2. Okay. Then you notice, oh wow, 2x plus 2x minus 2x can be cancelled out. So in the end, a product of binomials, of two binomials, ended up only having two terms after you have simplified it. Why? Because the cross terms are cancelled out. This is the beauty of difference of perfect squares. There we have the difference of perfect square formula. Okay, we have a plus b multiplied by a minus b, or sometimes because multiplication is commutative, you will see a minus b times a plus b, but they all equal to a squared take away b squared. It's always a minus sign here because you will always have a minus b, a plus b. Okay, so that's why it's a difference of perfect square. The cross term are cancelled out. Okay. Let's see an example. 3x minus 2y, 3x plus 2y. Okay. Now your a is your 3x and b is your 2y. So when you multiply 3x by 3x, you should have 3x bracket squared. I cannot stress this too much. You have to use a bracket here because you have to square both 3 and x. Okay? The same applies for 2y's. Okay? So since this is a squared, this is minus the b squared, and therefore you just square each terms, and then you simply arrive at 9x squared minus 4y squared.